Okay, today we're doing Module 1, Lesson 14, and your learning goal is to be able to use what you know about place value and also regrouping to help you divide decimals by whole numbers. This is very similar to what we did yesterday, except today we might have to do some regrouping, and I'll show you what that means in just a minute. Okay, but first let's talk about the problem of the day. Okay, when we have a division problem like this one, 6 and 72/100 divided by 3, we know we're taking 6.72 and dividing it into how many groups? Three groups. The first number, every part of a division problem has a name. The first number here, we call this the whole. Because before we split it into groups, we have a whole, right? So we're going to call it the whole. I know some of you might know there's another name for it, but in this class we're going to call it the whole. So I want you to label it whole. Then, the number that tells you how many groups we're splitting it into, in this case, how many groups are we splitting it into? Three. So the number that tells you how many numbers you're splitting it into, we call that the divisor. The divisor always tells you how many groups you're splitting it into. Okay? And then finally, we have a third number, don't we? That's going to be the answer. We don't know the answer yet, but that number is always called the quotient. Okay, so go ahead and label those three parts because sometimes I'll talk about the whole, sometimes I'll talk about the divisor, and sometimes I'll talk about the quotient. You need to know that the whole is the first number before you split it up. That's why it's called a whole. The divisor tells you how many parts you're splitting it up into, and the quotient is the answer. If I want to model this number, I'm going to draw how many dots in the ones place? 6. Okay, go ahead and do that. Okay, how many dots will I draw in the tenths place? 7. Okay, 1, 2, 3, 4, 5, 6, 7. And 2 dots in the hundredths group, right? Yes. Do you guys agree that this is 6 ones, 7 tenths, and 2 hundredths? Yes. Okay, now let's start sharing or dividing or splitting those dots up into the groups. How many groups are we trying to divide it into? 3, because my divisor is 3. So just like yesterday, I'm going to cross out one dot and put it in this first group. I'm going to cross out another dot and put it in this second group. Cross out a third dot and put it in the third dot group. Do I have more dots? Yes. Yeah, so I'm going to share them again. 1 into that one into the second one, and 1 into the third one. Do I have any more ones to share? No. I've shared all 6 ones equally into 3 groups. So how many ones are in each group? 2 ones in each group. Okay, let's move on to the tenths. So I'm going to put the first tenth, I'm going to cross it out and put it in my first group. Second one, I'm going to put it in my second group. Third one in my third group. Do I have more that I can share? How many more tenths do I have? 4 more tenths. How many groups am I trying to share them into? 3. Do I have enough to give 1 to each group? Okay, let's do that. So 1, 2, 3. Do I have more tenths left to share? How many tenths do I have left? 1. How many groups am I trying to share it into? 3. Do I have enough to share 1 to each group? Would that be fair if I put 1/10 in the first group? No. So what do we need to do? Regroup. I know that this 1/10, I'm going to circle it. It can become how many hundredths? 10. So go ahead and draw 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now that I've regrouped, is this tenth still there? No. So how do we show it's not there anymore? Cross it out. Very good. It's important that you cross it out after you circle it and regroup it. Otherwise, you might get confused and think it's still there. Okay, now let's share these hundredths. I have at least 3, so I'm going to put 1 in each group as I cross it off. Okay, do I have more? Yes. Okay. Do I have more than 3? Yeah. Okay, so I can share those. Now that I've done a second round, do I still have more than 3? Yeah. Okay. Now that I've done a third group, do I still have more than 3? Yeah. I have exactly 3. Oh, that's nice. Okay, so 2, 3. Now have I shared all of my place value dots? Yeah. Into how many groups? 3 groups. So if I take a look at one group, it will tell me what the quotient is. How many ones do I have? How many ones do I have in each group? 2. How many tenths do I have in each group? 2. How many hundredths do I have in each group? 4. So therefore, my quotient is 2 ones, 2 tenths, and 4 hundredths, or 2.24. Does that make sense? Yes. Very good. If we know that 6.72, this was the whole, right? Whole. this was the divisor, divided into 3 groups, is going to equal the quotient of 2.24. How can we check to make sure that's right? How can we check to make sure that our quotients are correct? Talk at your table group. Division and multiplication are what's called inverse operations. I want you to write this down. Inverse operations. What that means is they undo one another. It's like a zipper. If you multiply something up, you can divide it to undo it. They're called inverse operations. What that means is if you divide going this way, you should be able to do multiplication going this way, and it should be true. For example, 2.24 times 3, you can see I use the inverse operation of division, which is multiplication. It should equal 6.72 if we did everything correct. So let's double check and see if we did everything correct. Okay, if I have 2.24, I can rename that as 224 whats? 224 hundredths. Okay, and I have to multiply that by what? 3. Okay, so 3 times 4 is 12. 3 times 2 is 6 plus 1 is 3 times 2 is 6. So I get 672 hundredths. Is that what I want it to equal? Is that the same thing as 6.72? And we can see that check, that is correct. So you can always use the inverse operation for division, which is multiplication, to check to see if you did your work correct. Does that make sense? Yeah. Good. Let's try a couple more practice problems. If I'm going to model 5.16 in the top of my place value chart, how many dots do I have to draw in the ones column? 5. Okay, 5. How many dots do I have to draw in the tenths column? 1. And how many dots do I have to draw in the hundredths column? 6. Please do that. Now, we're going to simultaneously, at the same time, kind of like the transition words we're talking about in writing, right? At the same time as we do the place value chart, I'm going to show you the standard algorithm. For the standard algorithm, you'll always start with the whole. What's our whole? 5.16. Okay, go ahead and write your whole, 5.16. Your whole is always going to live inside the house. So draw yourself a house for the whole. And then the divisor is always knocking at the door. What's the divisor? 4. Okay, so this is how you set up your standard algorithm. Now, just like we're going to do the place value and the standard algorithm at the same time so that you can see how they are related, okay? We're going to work on the ones place first. How many dots do I have in the ones place? 5. How many groups am I trying to share it into? 4. Do I have enough to give at least 1 to each group? Okay, let's give 1 to each group. So 1 to each group and cross them out as you go. Okay. How many ones do we have left? 1. Is there enough to give 1 to each group? No. Okay, so we got to stop there for now. Once we shared 1 to each group, how many ones are in each group? 1. So let's write a 1 above the 5 in the ones place. When we gave 1 to each group, how many ones did we use up? 4. That's the same thing as 1 times 4. So right there that we used up 4. When we used up 4, how many were left? 1. Do you see how there's 1 here now left? Yeah. What do we do with that 1? Regroup. That 1 can become how many tenths? 10. Good. So show that it's going to become 10 tenths. When it becomes 10 tenths, how many tenths do we have altogether? 11. That's the same thing as bringing down this 1 in the tenths place. Do you see how now we have 11 tenths? Do you guys see that? Imagine there's a decimal point here. Is that 11 tenths? Yeah. Okay. So now do we have at least enough to share 1 to each group? Yeah. Okay, go ahead and do that. 1 to each group. Okay, how many tenths do we have left after we share 1 to each group? 7. Is that enough to give 1 to each group? Yeah. Okay, do that again. 1. Okay, how many do we have left now? 3. Is that enough to give 1 to each group? No. So we had to hold on for now. Okay. How many did we get to each group? 2. 2 whats? 2 dots in which column? 2 tenths. So you're going to write a 2 up here in the tenths column. Don't forget to put this decimal point to show that that's the tenths column. How many tenths did we use up altogether? 8. So down here, we're going to write 8 tenths. How many tenths do we have left over? 3. 3. So then 11 minus 8 is 3. Do you see how that works? Okay, what are we going to do to these 3/10? We're going to regroup them so that they become what? 30. Now, okay, and after sharing 9 dots to each hundredths group, how many hundredths are left? 0, because how many did we use up? 36. So there's nothing left. So, do you guys see how the standard algorithm is the same thing as the place value chart? Yeah. So what's the quotient? And do you guys see how that's the same thing? If I look at to see what's in one group right here, how many ones do I have? How many tenths do I have? How many hundredths do I have? Now, how can I check my work to see if I did this correct? I need to multiply. To check, I need to multiply the quotient. What was the quotient? Okay. By the divisor. Remember, because I'm going backwards. Right? So what's the divisor? 4. And the answer should be, if I'm correct, what? 5.16. Okay. So let's think to ourselves. 1.29 is the same as 129 what's? Hundredths. Okay. And my answer then will be in what units? Hundredths. Okay, let's multiply. 4 times 9 is? 36. 2 times 4 is?
8.
Plus 3 is?
11.
Okay. 4 times 1 is?
4.
Plus 1 is?
5.
So I have 516 hundredths. Is that what I want it to be?
Yes.
It's 5. Oops, I shouldn't write it like that. 516 hundredths is the same as 5.16. Yes? Is that what we want it to be?
Yes.
Very good. So we can feel confident that our answer is right. If we always know how to check our work, should we ever have